Hi everyone. This is going to be a quick demonstration of how we calculate confidence intervals for a mean. So here's an example question. We have 15 different farms in Bundaberg. Well, that's a sample of 15. There's probably a lot more than 15 different farms. And they're talking about how much area they had planted with tomatoes. There's the numbers. And they're in hectares. We have to use this data to estimate a 90% confidence interval for the average farm area devoted to tomatoes in Australian farms, and then state any problems with our estimate. Well, the first thing we need to do is find the sample mean and the sample standard deviation as estimates of our population parameters. So the sample mean, if I get myself organised here, the sample mean is as we know, the sum of the scores divided by the number of scores. Then the sample standard deviation is the sum of the scores subtract the mean squared divided by n take 1. Remember, n take 1 for the sample. Now, I am not going to perform those calculations manually. That would be ridiculous. So I'm going to use my graphing calculator. Go to the menu and cross here onto the statistics app. Now I've already entered the data, so you see 12, 14, 16, and if I run all the way down, it's all there. Now I'm going to press calculate and then always check the settings to see that it's a single set of data, so it's one variable stored in list 1. Each data number appears once. That's correct. So here's there it is. The mean is 18.46 and the sample standard deviation, be careful not to use sigma, use S, 10.842. Let me just write those numbers down. We had a sample mean of 18.467 and a sample standard deviation was 10.842. Now, there'll be a little bit of rounding, but 3 decimal places should be fine for this. Now, we need a 90% confidence interval. So let's for a minute think about a standard normal curve. So a standard normal curve, the mean would be 0. If I want an area between the upper and the lower boundaries, so that's Z lower and that's Z upper, if I want that to represent 90%, then this would be 45% on either side, wouldn't it? So remembering that alpha is the cumulative area from the left tail, that would be 0.5 plus or minus, well, I'll write the original 0.9 divided by 2. So I have here that the value of the quantile at the lower limit here would be 0.05, and then it would range all the way up to 0.95. It would be good to turn those into Z scores, wouldn't it? So what would be the lower and the upper Z score? Well, fortunately, I have a graphing calculator to help me. That's the sort of thing that we could have used a table of standard normal curve table for in the past, but now we just use our graphing calculator. So I'm going to go to here and I will go options, statistics, distribution, normal curve, and it's an inverse normal because I know the area but I want the. Now I first, in the syntax for Casio, I first have to put the value of alpha, then the standard deviation, and then the mean. And it's 1 and 0 for a standard curve. And I'll store that in Z. It is, after all, a Z score, isn't it? It's negative 1.645. Now, of course, because of symmetry, the upper Z score will be positive 1.645. So far, so good. We're nearly at the point of getting our confidence interval. Before we do a confidence interval for the mean, we have to work out the standard error of the mean, don't we? or the standard deviation of the means. Remember, that would be sigma divided by root n, but we don't know sigma, which is a population parameter. We only have a sample, so we'll say this is approximately S divided by root n. Now we had 10.842 for this, and we'll divide by the square root of 15. There were 15 farms in our sample. So back to the calculator. I need 10.842 divided by the square root of 15. And I should have stored that. I'll store that under letter S because it's standard deviation of the mean there. So that's 2.799. Just write that down before I forget. Okay, I've got everything I need now in order to calculate my confidence interval. So the confidence interval equals, we'll have the mean, we will subtract the lower z-score by the standard deviation of the mean, then we'll do the opposite. We'll take the mean and we will add that z-score, the upper z-score, multiplied by the standard deviation of the mean. So what was our mean? Our mean was 18.467. Our z-score was 1.645. And our standard deviation was 2.799. Now we do the same thing, but we add. Now, something to remember, this part of the calculation is sometimes referred to as the error margin. So that's something you might see occasionally in a question. Now this wouldn't be too difficult, I hope. Let's go. So our mean was 18.467. We are going to multiply by the value we stored as a z-score, and then we're going to multiply by the value we had as our standard error. Did I say? I've done that wrong. That should have been add, and that should have been multiply. Sorry about that. So I've got my lower value of 13.86. And for the upper value, I'll just need to go and add instead of subtract that time. And that's 23.07. So there's my confidence interval, and that's the end of the question as far as the mathematics is concerned. There was a little bit there that said, state any problems with your estimate. Well, the most obvious problem is my sample only had 15 items, and for confidence intervals we generally want our sampling distributions to be 30 or more items. The other problem would be a regional bias. Perhaps Bundaberg is a very good climate for growing tomatoes, and there would be other regions of Australia which are not so good for growing tomatoes. So to get some sort of a confidence interval for all of Australia, you really need to be doing some samples from different regions rather than one localised area. That's the most obvious things I can think of that would be a problem with the analysis there. But there's the mathematics of it. Showed you how to use the calculator. That's enough for this lesson. See you next time.